So when calculating average atomic mass and dealing with sig figs, it can be a little confusing, so I want to walk you through the process. I think calculating average atomic mass, that should be an easy process for you, but sometimes dealing with sig figs is tough. The thing you got to remember with this in doing sig figs is that when you shift from multiplication, where you're multiplying the mass of each isotope by its percent abundance, you round for sig figs then because you're shifting from multiplication and then you're doing addition. And so anytime you transition from multiplication to addition or division to addition, you've got to deal with sig figs in between. So let me set this problem up for you. We've got three isotopes of argon. We've got argon 36. And so I'll just start with that one. Let me make my pen a little thinner here. And we're told that argon 36 has a mass of 35.97 AMU, and it has an abundance of 0.337%. So I'm going to go ahead and just put that over 100. And then we have argon 38. And argon 38 has a mass of 37.96 AMU and an abundance of 0.063, so 0.063. And divide that by 100. And then we have argon 40, and that has a mass of 39.96 AMU and an abundance of 99.600%. So I'm going to divide that by 100. So now I've got my calculator. 35.97 multiplied by 0.337 divided by 100. And so when I do the math there, I get 0.121218.9. And then on this next one, 37.96 times 0.063 divided by 100. And on that one, I get 0.239148. And then on the last one, 39.96 times 99.600 divided by 100. And on that one, I get 39.9, 39.800. And so technically the next step I'm doing is addition. So before I do the addition, I've got to round these to the right number of significant figures. And so over here, I've got 4 significant figures in the atomic mass for argon 36, but I have 3 significant figures in the percentage. So that means I need to round this first number to 3 significant figures. So that's 0.121. And then on this next one, for argon 38, I've got 4 significant figures here, but only 2 significant figures in the percent abundance. So then that means I've got to round that to 2 significant figures, so 0.24. And then down here with argon 40, I've got 4 significant figures in the mass, and I've got 5 significant figures in the percentage. And so I need to round this number here to 4 significant figures. So that gives me 39.80. So now I've got to add all those up so that I can get the average atomic mass of that isotope. So 39.80 plus 0.24 plus 0.121. And that gives me a grand total of 40.161. Well, now I've got to apply the rules for addition and subtraction with sig figs. And that rule says you can't have more digits to the right of the decimal than the measurement with the fewest number of digits to the right of the decimal. Well, right here is our measurement with the fewest number of digits to the right of the decimal. That has 2. as does the bottom measurement. Right, we've got 2 digits to the right of the decimal here. So our answer can't have more digits to the right of the decimal than the measurement with the fewest. Now, I got to look at this. I got to look at my numbers here and realize that something went wrong somewhere, because I can't have a average mass of 40 when all of my numbers are between 35 and 39. So I need to go back and check my math somewhere along the way. So let me double check those numbers, because clearly I've made a mistake somewhere. 35.97 times 0.337 divided by 100. Okay, so that first number is correct. 37.96 times 0.063 divided by 100. There it is. I dropped a 0 in that second number. So let me go back and fix that. Whoops, that erased way too much. Make that a little smaller. So these numbers are different, which is going to affect this number here. So you've got to have your brain engaged when you're doing this. Let's see. So calculator spits out 0.0239148. I've got to round that to 2 significant figures, so that's 0.024. And so there are 3 digits to the right of the decimal there. So I've still got to round my final answer down here. All right, I've got 3 digits to the right of the decimal in the first number for argon 36. I've got 3 digits to the right of the decimal for my answer for argon 38, but only 2 digits to the right of the decimal for argon 40. And so I've got to change, right? I've got to make sure my answer gets rounded to only 2 digits. So let me give you the full calculator answer first, 0.024 and plus 3980. My calculator spits out 39.945. Now that answer makes sense because it's between my smallest of 35.97 and my largest of 39.96. And we would expect the answer to be close to this 39.96 because of the high relative abundance of argon 40. So let's go ahead and round this then to 2 digits to the right of the decimal. So we should have 39.95 atomic mass units as our final answer here. I hope that makes sense. Let me know if you have questions.